This is example 5.4 from Discovering Design with Chemistry. The first question in this example says, what is the shape of HCN? We did this Lewis structure in example 5.2, so I'm not going to redo the Lewis structure. We're just going to jump straight to the bond. Now for this one, you can see that there is a bond here, a single bond, and a triple bond here, which means this middle one only has two bonds coming off, or two groups of electrons. And so because it only has two, this one's linear. And so if we drew this one, well, it doesn't ask us to draw it, so we will just write it. It's linear. But if we were going to draw it, we would just continue to draw it in the same shape as before, with it spread in a line like that. In the second question for example 5.4, it asks us, what is the shape of NCl3, and draw a stick figure in an attempt to illustrate the shape. So again, we've done this Lewis structure before in example 5.1, so I just went ahead and drew this one on here. If you can't remember how I got that, just go back and watch 5.1. In this case, the movable groups are 4. There's one to this side of nitrogen, one to this side, one to the bottom, and one on the top. However, that top group isn't going to show up in our shape because it's just a pair of electrons and it's not a bond. But we still have to consider, like, we've got four different things. So the shape is going to be pyramidal, like a pyramid, and so we're going to try to draw this. So that means, imagine when we have the tetrahedron, we have one kind of up and then the other three kind of go down like a, see if I can do it, like a three-legged stool, like in 3 different directions. And so for this one, we're going to have one of the CLs can be right there on the same plane. One of them kind of has to stick out, so I'm going to make it kind of get fatter as it goes out, so you can see it's kind of coming out from the page. And the other one's going to be like it's going back into the page. I'm not sure that I did that very well because drawing is not my talent. Okay, it's kind of supposed to look like it's going back into the page. As long as you draw a dotted line, I will count that. And it doesn't have a top because as bonded, these electron pairs, it's not a bond, and so we don't draw that. So it just stays like a pyramid. Okay, and then in the third problem from this example, what is the shape of F2SiO? So I went ahead and got from the periodic table what column each of these were in, so we don't have to go back and forth with the camera. So I have my two F's, which have 7 electrons around them, which means I'm gonna pull out my dots in a minute, but basically they've got 7, so they've only got 1 space. So that's got 1 unbonded pair. And then the Si is gonna have 4, so it's gonna have 4 on each side. I mean 1 on each side of all 4 sides. And then O has 6, so 1, 2, 3, 4, 5, 6. So the F has 1 side, this has 4, and this has 2. So the one with the most unbonded electrons, unpaired electrons, is the Si, so that's the one we're going to start with. So let's erase these extra dots and get started. So let's put that in the middle. It needs 4, so 1, 2, 3, 4. And then we'll go ahead and put our F's and our O's around it. So let's put them around the sides. So remember, our O needs 6. So 1, 2, 3, 4, 5, 6. All right, so we're going to first start by just spacing them around them like we usually do. And you can see how the went ahead and started making pairs there. And this one has a nice little pair here. This one doesn't, so we're probably going to move it in here. But let's go ahead and finish out our flooring. Not our flooring. Our other one last. All right, let's see. We needed 7. So this one's easy. I'm just going to go ahead and put that one that's going to be unpaired with the green one, because we know that's how it's going to finish it off. All right, so that one's finished, and there's a single bond there. And then one down here. We're going to go ahead and finish off that with another single bond. There we go. All right, so these are finished. I can keep them in line. We have a single bond here and a single bond here. This one is unbonded or unpaired. This one's unpaired, so we're going to fix that. And so now we have a double bond going on here to make those two paired. So let's redraw this. So we have SI in the middle. We have a single bond on this side. We can finish drawing the dots that are there. We have a single, oh, you're not even able to see what I'm doing. We have a single bond coming down from that to the other F, and then we can go ahead and add the extra dots that are there. And then we have a double bond going to the O with two of the sides filled up. So if we look at just the middle one, how many different movable pairs do we have around it? There are only 3. There are these 2 single bonds here, and then there's a double bond here, so it has 3 bonds, which means that it's not the, don't let it fool you like this one that appeared to have 3 sticks, but it also had this set of paired electrons at the top, so it really had 4 different sides of that nitrogen that had something going on, or 4 movable pairs or bonds or whatever, 4 things going on around the nitrogen that we had to deal with. So even though the nitrogen didn't have anything come out of the top, we still had to kind of pretend like there was something here. I'll put a thought bubble. So we had to think of it like in that shape, almost like the tetrahedral shape, but it turns into a pyramid because it doesn't have a top. In this case, there is no top. There's nothing up there. And so we only have 3 sides. And when you only have 3, it becomes triangular. So this one didn't ask us to draw it, it just asked us to say what it was. So we can just say trigonal, like a triangle. And then we don't have to draw it, so we're not going to.